All right, welcome. My name is Ryan Holger with Temperature Equipment Corporation. Today is Monday, November 25th. This week's webinar topic will be modulating gas furnaces. Specifically, we're going to focus on the Bryant Evolution 987M model and the Carrier Infinity 59MN7 model. We'll talk a little bit about a few of the regular basic furnaces as well, but we're going to focus on those two modulating gas furnaces. As you guys probably know, and you've probably seen me show you this chart a billion times by now, but heating residential spaces is a big energy component as far as energy consumption in the entire United States is concerned. And nationwide, it's about 45% of our energy consumption residentially. And then obviously, if you're here in the cold Chicago area, it may be a little bit more than that even. So having a very efficient furnace relative to, fantastic cooling and lighting and water heating systems is way more important than most of the other appliances in your home. Just real quick, the full Bryant and Carrier offerings, so you can see where these furnaces kind of lay in that offering. On the Bryant side, there are 3 tiers of products, as most of you guys probably know. There's the Legacy line, the Preferred Series, and the Evolution systems. On the Legacy line, both of those guys, let's see if I can get my little spotlighter guy, both of those have PSC blowers, which are just regular basic efficiency electric motors, and they're single-stage heating systems. There's a 92 and a 95% model available in that line. When you look over at the Preferred Series, there's actually 3 furnaces in that line now. It used to be just 2, but now there's a new entry-level one, which is a 92% efficient furnace with an ECM motor, single-stage, 95 with an ECM single-stage, and a 95 with a 2-stage gas ECM. Kind of how those guys line up. And then on the Evolution side, there's actually 2 furnaces, the 986T and the 987M. The 986T is in the middle of a transition, just so you know. It was 986TA. The new one is 986TB, and the only real difference is going to be that it's switching from a non-communicating variable speed motor over to a fully communicating variable speed motor. So previously, you were not able to use that furnace, the 986TA. You were not able to use it with Evolution zoning systems or for dirty filter pressure drop sensing and those kind of things. The new 986TB eliminates that problem, and now you can use it in all Evolution applications. And then there's the furnace that we're actually going to look at today, which is the 987M. M stands for modulating. So if you didn't already know, the 8 stands for Evolution, the 7 stands for a minimum of 97%, and the M stands for modulating gas. So this guy ranges from 97 to 98.3% AFUE, depending on the model number. It's modulating gas heat, a fully communicating, two-way communicating variable speed ECM motor, a variable speed ECM inducer motor as well, in addition to the blower motor. Look at the Carrier side, it's very similar as you might expect. It's Comfort Series. There's a 92 and a 95% model. Both of those are single stage. Both of those use PSC blowers. There's the Performance Series, which has the 95% plus, which actually should be called 96 because all the sizes hit 96% now. 2-stage gas heat with an ECM motor. There's a 95% with single-stage heat and an ECM motor. And there's the new 92% single-stage ECM motor. So everything in the Performance Series is ECM. Everything in the Comfort Series is a PSC basic efficiency motor. And then everything in the Infinity Series is a variable speed motor. On the Infinity side, just like with Bryant, there was a 2-stage and then a modulating gas. We're going to focus on the 59MN7 modulating gas unit with full 2-way communicating variable speed motor and variable speed inducer motor. Tony asked a question if the T is for 2-stage. I don't know if he's talking about Carrier or Bryant. So on the Bryant side over here, the M is for modulating, the T is for 2-stage, the S is for single-stage. On the Carrier side, very similar, the M in the model number modulating, T 2-stage, and then if you go over here, S for single-stage. So it's similar idea for both of those kind of lines. And Matt asks what a PSC stands for. PSC is permanent split capacitor. It is your basic residential non-efficient blower motor. The ECM is electrically commutated motor, and that comes in 2 flavors. There's what we call the X13 version, and there's a full 2-way variable speed one. The regular X13 ECM motor, it's an ECM motor, so it's a DC motor, which is fairly efficient, and we can dictate to it a couple different speeds. I think that motor has 5 different speeds, and we typically use 3 of them with a furnace, will tell it, go to this particular speed for first stage heat, first stage cooling, or just recirc mode. Go to this other higher speed for cooling, and go to this other higher speed for two-stage heating. The variable speed ones ramp all the way up and down. So it's still an ECM motor, but it's got controls on it that allow it to ramp fully through a range from, let's say for sake of argument, 30% to 100%. All right, so we're going to focus on the modulating gas ones. Jimmy actually asks to explain ECM and PSC one time. I must be talking very quickly. PSC is permanent split capacitor. ECM is electrically commutated motor. PSC motors are AC motors, basic efficiency, probably the least efficient thing you can legally have. An ECM motor is a DC motor, direct current motor, and it is more efficient and more controllable with more speeds. And then a variable speed ECM is infinitely more controllable. All right, so focusing specifically on the modulating gas versions of these Carrier and Bryant units. Let me go back to normal mouse here. So some benefits to these units. These are very quiet units. Most of you guys have probably seen the sound data or heard the video recordings or perhaps even seen one of these operating. These are very quiet units. The gas valve is fully modulating. It goes from 40 to 100% in 1% increments. So 40, 41, 42, etc. So it's basically, if you want to think of it this way, a 61-stage gas furnace, right? Whereas normally we'd have 1, 2, or 3 stages. This is 61 stages. So just right there, you can kind of see how much more controllable it's going to be and how much more comfort it could possibly provide. It is a fairly attractive unit. The Carrier ones have these curvy features. The Bryant ones have these what we call muscular features, but nonetheless, it's just a appearance on the door. And for some people that matters, other people it doesn't. But if people are into the aesthetics, great. Oh, isn't that clicking? Oh, there you go. The height is pretty short. These are 35 inches. For you guys that have used Carrier and Bryant furnaces, prior to 2012, you probably know they're like 40 inches tall. So these guys are about 5 inches shorter than any Carrier or Bryant that you might be replacing at someone's house. So that does give you some more room to install widgets and accessories like humidifiers, RGF light bulbs, and that kind of stuff that needs to be on the discharge of the evaporator coil, or even higher, taller evaporator coils. As you know, some of these ones have gotten pretty ridiculously tall, so the shorter height furnace gives you that flexibility. Keith is asking if Carrier uses a different gas valve than some of the competitor models that modulate from 35 to 100%. Carrier does do something quite different on the gas valves. I don't know if they use a different manufacturer, but there is definitely a different control sequence of operation. Most other manufacturers of modulating gas furnaces, they use algorithms to calculate how fast to ramp the gas valve up, and we do that too, obviously. The difference is most of our competitors ramp the gas furnace up until eventually it satisfies the thermostat, and then it shuts the furnace off. And then 5-10 minutes later, whenever it is, there's another call for heat, and they turn the furnace back on at a calculated predictable starting point based on the previous cycle, and then they ramp it up again from there. What we do differently is we don't shut the furnace off. We continue to leave it on, and instead of shutting it off, we ramp it down. We ramp it up and down continuously to always give you the exact number of BTUs that you need to satisfy the demand. We'll kind of explain that a little bit later on today. So there's definitely a difference in how the gas valve operates compared to non-Bryant and Carrier systems. It's a two-door front panel design. So previously you might have known 2012 and earlier, Carrier and Bryant furnaces had a single panel. You took the panel off, then you had another panel to take off. It's no longer like that. The top is one section, the bottom is another section. When you take the front door off, you are fully into everything. You have complete access on the service side. There's no additional panels to take off. And then obviously all these doors you can see come off with 90-degree turn knobs instead of having to use screwdrivers, obviously. Obviously that's what it looks like on the inside. As you would expect, the blower is on the bottom, circuit board is on the bottom. On the top is your heat exchanger, both your primary and your secondary heat exchanger. And we'll go through each one of these pieces in a little more detail. But this is your primary heat exchanger here, right? And here's your combustion burners. So the gas is flowing through your gas valve up through your burners. This is a 1, 2, 3, 4 cell system. So we got 4 different burners, so it's a reasonably high BTU unit. Gas flows to the primary heat exchanger, and then it works its way down through the secondary heat exchanger, which are these tubes down here, to get more heat transfer capability. And we'll go through those in a little more detail. Oops. So we've got a fully modulating gas valve, and it's combined with a fully variable speed blower and a variable speed inducer motor. So we got three things that are modulating here in conjunction with one another to get you the right heat transfer BTUs. We have two airflows, right? One airflow on the combustion side of the heat exchanger, one airflow on the space conditioning side of the heat exchanger, and then we have the gas flow that we're modulating. So all three variables are in fact modulating, and that's one of the reasons why we need to have this system utilized with an Infinity touchscreen thermostat or an Evolution Connects thermostat. We don't run these modulating gas systems with a regular thermostat. They need to be operating with those communicating thermostats because there's going to be additional data that they need from the thermostat in order to function correctly. And we'll explain that here in a little bit. The primary heat exchangers are aluminized steel. Obviously, the aluminized part is there to help protect against corrosion if we get a little bit of condensation in the primary. And on the secondary heat exchanger, it's a stainless steel heat exchanger. And obviously that is there for corrosion protection as well. On secondary heat exchanger, we definitely will be condensing, which means we'll have moisture. Moisture on metal don't play nice, so if we use stainless steel, that problem goes away. On these modulating gas furnaces, they are 97% AFUE in all orientations at a minimum, and sometimes even higher, up to 98.5% for the size 60,000 BTU version. So the worst is going to be 97, the best is going to be 98.5, and it's all orientations, meaning upflow, downflow, horizontal left, horizontal right. As you probably know, this furnace, along with all of the other furnaces in the condensing furnace lines from Carrier and Bryant, can be installed in any orientation. There are no dedicated models that require you to have a certain model number to be able to put it, say, downflow or horizontal or something like that. Every single model is fully multi-poise, which means we can rotate it in any direction. There's a few things we'll have to do to modify the unit, and I'll show you those in a second, but they are very easy and take less than 5 minutes. By the way, this 98% furnace, the 98.5% one, which is the 60,000 BTU size, that guy is the absolute highest furnace that you can find through AHRI directory. There's no furnace that's more efficient than that particular one, so it's pretty good selling thing there. Like we said, there's lower heights. There's also a varying widths. There's a 14-inch width, which is smaller than we traditionally have done on some of these condensing furnaces. That is a good replacement for some of these, small 40,000 BTU, closet-style units. Now you can replace those with a condensing unit and fit it into the existing closet. There's a 17-inch width, as you might expect, 21 and 24. And obviously the width of the furnace is dependent on how much airflow we need, so that's associated with the amount of BTUs. So larger furnaces with larger blower drives will have wider cabinets, and smaller ones with smaller blowers will have smaller cabinets, as you might expect. All the venting can be done through the top of the unit, or the sides of the unit, or even actually through the bottom, and I'll show you what has to be done to modify it to do that. So we'll kind of go through that. The blowers actually slide out. They're on chassis rails, so you take a couple screws out and you can slide the entire blower assembly out to make it more serviceable. The circuit board is very accessible from the front end of this guy, and the front doors come off very easily. There's 2 quarter-turn knobs for each panel, and they're off. No tools required to take the door off. This gives you a better view of what the heat exchanger looks like on the inside. Like I had said, let's see if we can get this back over here. This is a 4-cell heat exchanger in this particular model that we're showing you here. All your burners are up top here. Combustion's happening in this point. All of our flue gases are coming through, wrapping around the back, passing through again. And it looks like they zigzag up and down, but they really do move kind of straight through here. The zigzagging look there is to get us more surface area to get more heat transfer and hence more efficiency. And they wrap around the back side over here. And then all the gas comes through these individual tubes. There's 3 rows of them here, as you can see, multiple columns. We're going through all these stainless steel tubes, and there are fins on those tubes to help spread the heat out. And then you probably can't see it very well in this picture on the webinar, but you might see little tabs sticking out of each one of these guys. Each one of those little tabs sticking out of each one of them is a little turbulator. If you were to pull that tab out, it would be a corkscrew piece of metal. And the whole idea with that is as the gas is flowing through these tubes, that corkscrew piece of metal is causing the gas to mix around, and hence the gas touches the outside of the tube more frequently and transfers a little bit more heat. So just kind of scrubbing a few tenths more efficiency out of this system. So on the positive side, there's quite a bit of things that are going on here to increase efficiency. On the negative side, if you're used to old Carrier and Bryant furnaces, this one does have tighter airflow paths on this side of the air exchange. So cleaning could be a little bit more important, or filter changes can be more important depending on which way you look at it. Change the filters more regularly, or wait for them to get filthy and then have to clean the unit. So the positive is efficiency, the negative is a little bit more maintenance, but stuff they should have been doing anyway. If you guys continue to have any questions, please do type them in the chat box in the bottom right-hand corner of your screen, and I'll try to pay attention to those and ask them, or excuse me, answer them. And I believe we are all caught up with the questions at the moment. These furnaces can be pretty much installed in almost any scenario for replacement purposes. So the combustion air can come in the top of the unit, it can come in the left side or the right side, the gas on the left or right, the condensate drain left or right, the return air left, right, or bottom. So everything's pretty flexible in terms of whatever you're taking out of the system, whatever furnace is coming out versus which one you're putting in. If you do flip this furnace on its side, just note that the nameplate, Carrier or Bryant, will be on an angle. If you flip it upside down, however, you can pull the nameplate off and push it back on upside down, and then the nameplate will be correct in the downflow configuration. Like we said, the combustion inlet air can be on the left side, as I'm highlighting right here, on the right side or on the top, and then the exhaust vent, left side, top, or right side as well. Each one of these guys, each penetration, whether it's a vent pipe, combustion pipe, gas line, electrical connection, whatever, each one of them is going to ship with some kind of grommet to fully enclose that unit. So I don't want to put a gas pipe to the side of this cabinet and have an air gap between the gas pipe and the cabinet. There's a grommet that comes with that you'll install over the pipe to keep this guy reasonably sealed combustion. The top half of this furnace is a sealed combustion chamber. So if I punch holes in it to run pipes through it, I want to make sure those are sealed back up. Those grommets do come with the furnace in the loose parts bag, but it seems that sometimes the loose parts bag becomes the lost parts bag. So do pay attention to that bag that comes in the furnace and save those pieces. You will need them when installing it. This here is to illustrate a couple different things. For one, on the right-hand side over here, we got this venting elbow, right? This guy over here. That vent elbow can rotate in any direction. So if I got it in the upflow configuration and I want the air to go up, I'm already in good position. If I want the air to go out the side, I can loosen up this clamp, which basically looks like a radiator hose clamp, and then I can rotate this guy around and then vent him out to the right. I could vent him left. I could vent him down depending on my scenario. I'm not going to vent him down in an upflow configuration, but if I flip the furnace upside down, then I would rotate the elbow 180 and down becomes up, if you will. So if I want to rotate this entire furnace and throw it on its left side, its right side, or completely upside down and make it a downflow, I do have to change that venting elbow. That's for sure. That's this guy right here, right? Another thing I got to pay attention to is I got to pay attention to the condensate trap. This is where all the water is going to eventually collect and dump into before it goes out the PVC pipe and drain away. I can't have that condensate trap on the top side, obviously, because water will not flow upward. So if I flip this guy, this whole entire furnace 180 degrees, right? I flip them 180 degrees. Now this condensate trap is going to be over here on the top left side. So I have to actually move him. So if you notice here, there's a couple little plugs on the left side over here, collector box plugs. I take those out. I move this condensate trap over there. I put the plugs on the other side. Life's good. I'm ready to go. So if I want to rotate this guy, all I got to do is rotate the venting elbow and flip-flop the condensate trap, and I can move this guy into different orientations. Those are the only two things I really have to move around. The condensate trap is not clear. Originally it was supposed to be clear, and that was so we can see if something was clogged in there, which is obviously a great service technician troubleshooting feature. However, homeowners complained that they didn't like seeing water and slime and things sitting in there. So we got rid of that idea. And now the front of it is opaque, meaning it's fully colored, either black or white, depending on which version of the furnace you have. And the back of it is still clear. So a technician could take the condensate trap off, the collector box off, see the back side, and then know if it's plugged or not plugged. The front of it's not visible anymore. Like I said, on the venting, we can go out the left side, the right side, or out the top. You got your choice on that. This is an upflow configuration for the furnace, meaning that air is moving up through the furnace this way, right? So I can bring my combustion air and exhaust from the top, left, or right. If I go to the downflow configuration, that means I flip my furnace a full 180 degrees, right? And now my airflow is moving in this direction. So that means my combustion air can be the left, the right, or obviously I can't go at the top anymore because the top is now down and I don't want combustion going down. But I could run it through the blower housing if I want to. I would generally recommend not doing that for two reasons. One, running combustion air through my regular airflow assembly sounds like not a good idea to me. And for two, more practically speaking, it blocks my access to the circuit board and the blowers. But if for some reason you need to do this, you got a really tight closet and you want to have downflow air running through this guy and you can't vent out the left or right and you got to vent back out the top or the bottom as it is now, you can't do that. You got to get an accessory internal venting kit, and then that basically comes with the little penetration grommets to seal those up so that way you can have a full continuous pipe going through your blower housing without having to worry about air leaking through there. I can also vent this horizontally to the left or horizontally to the right, and I can have my vent pipes coming out the top, which is now the left, the right, which is now the top, if you will, or I can have them venting out through the blower housing if I get that internal vent kit, and I would avoid doing this unless there's no other way to vent it out. You will also notice when you lay this thing on its side, that collector box that used to be over here now has to be located over here, and it's going to penetrate below the cabinet a little bit. So just keep that in mind when you're installing it, that this furnace can't be laying flat on the ground. It's going to have to be on little blocks or something like that in order to keep him elevated up so the condensate trap can be on the bottom, right, because water has to flow down. This is a blow-up of what that venting elbow looks like. So like I said, all you got to do is basically loosen up this clamp, which looks like a radiator hose clamp, and then you can rotate this entire assembly 90, 180, or 270 degrees to vent it the direction you want. There's another clamp on the other side of it over here that clamps onto your PVC pipe going out the unit. All right, on the venting side, the venting is actually very beneficial in terms of what's allowed with this unit. And I'll show you the tables here in a second. So we do it based on maximum equivalent length. So that means that we're going to give you a total equivalent maximum you can do, a certain number of feet. And then within that number of feet, it counts for all the actual length of pipe as well as any penalties for elbows and joints and things like that. The tables do go up to 4 inches, which means you can vent it pretty far. We'll show you that. And there is another table that is available you can look at if you need to run some of this piping outside. And basically, it's going to have you using insulated pipe in order to do that if you want to run it outdoors with really cold temps. These furnaces either need to be installed in a 2-pipe vented scenario, meaning I have 1 pipe from outside coming in with combustion air, 1 pipe leaving with the exhaust air, or you can ventilate them with the ventilated combustion air method. What you cannot do is you cannot do a single pipe venting, which means you steal air from the room and exhaust out on the exhaust pipe. So you either have to get the air directly from the outdoors or you have to get it from a ventilated combustion air space. Those 2 types of spaces typically are the crawl space, like we're showing here, right? So the furnace is over here somewhere, and we got the intake pipe coming from the crawl space instead of coming directly from the outdoors. And the crawl space has to be ventilated, obviously. Should go without saying, but I'll say it anyway. The other choice is the attic, right? The attic is another space that could be ventilated. So I got the exhaust pipe leaving the furnace and going all the way out of the house, right? Penetrating through the roof all the way out of the house. And then my combustion pipe, instead of bringing it from the fully outdoors, I can bring it the combustion air from the attic itself, assuming that the attic is ventilated as well. Right? So I can do 2-pipe, where I got the pipes going fully outside, or I can do ventilated combustion air, which is kind of like 1 pipe, kind of like single pipe, but I'm not stealing from the space. I'm stealing from a ventilated space, like the ventilated crawl space or ventilated attic. This is a little different than some of the non-modulating units that you've probably worked on from Bryant and Carrier that do allow single pipe. These guys don't. I only showing you the first part of the vent table here. There's no reason to show you the higher altitudes because in the Midwest here, we are never above 2,000 feet, so the table gets really simple here. So if I want to look at some examples, let's say I take a 80,000 BTU furnace. If I want to run 2-inch venting pipe, I can go 130 feet with that guy. Right? So that's how far I can go with him. If I want to run 3-inch, I can go 235 feet, 4-inch, 265. Right? So these are the different tables you can have. If I have a larger furnace, 100,000 BTUs, it's telling me you can't do it in 1.5-inch pipe. You can do it in 2-inch, but you can only go 50 feet. You can do it in 2.5 for 110, 235, 265. Although I don't think anybody's going to be buying 2.5-inch pipe, but nonetheless. Bronson is asking if 2-pipe is not allowed for operational or efficiency reasons. Operational reasons. If you read the installation manual, you're specifically prohibited from doing it. It's not saying that you're going to have lower efficiency. It's prohibiting it. And in general, I don't know that taking outside air would lower your efficiency anyway. You'd actually have colder air, which means colder combustion air, which means you would hit the condensing mode sooner, and you very well may be able to extract more BTUs. So I'm not sure there's any argument there. But it's for operational reasons. If you try to do a single pipe installation on the modulating gas furnaces for Bryant and Carrier, meaning you take combustion air from the house itself, you will void the warranty of the unit. All right, so that's how many feet you can run it, right? So let's take our example of 80,000 with 2-inch venting pipe. I can go 130 feet. Let's use that as our example. So I get to 130 equivalent feet. So that's actual linear feet minus any deductions for any of my elbows and things like that. So since I picked 2-inch pipe, I'm in this column over here, right? My venting is already included in that number, so there's no additional penalty for that. They've already assumed we're going to have some kind of venting termination, so I've already got that, included. And then depending on what type of elbows I use, I get bigger or smaller penalties. 90-degree elbows, if I can have a long radius, medium, or a mitered radius, it's going to have a different effect on there. So let's just say I have a medium radius, 90-degree elbows. Those are worth 5 feet. Let's say that I have 5 of them for some reason. So that's 25 feet of penalty. So now instead of 130 feet, I can run my venting pipe 105 feet. So you can see kind of how that works there. Getting a lot of questions about the 2-pipe discussion. Right now we're specifically talking about the modulating gas furnaces, so the 987M from Bryant and the 59MN7 from Carrier. Those are the ones that must be 2-pipe vented or ventilated combustion air where you steal it from the crawl space or the attic, assuming those spaces are ventilated fully to the outdoors. Fully to the outdoors meaning I have soffit vents and ridge vents to allow air to come through the attic and on out. I cannot steal it from an enclosed attic. I cannot steal it from enclosed crawl spaces. I cannot steal the air from basements or living rooms or anything like that. The combustion air has to come directly from the outdoors. But we're specifically talking about the modulating gas furnaces today. The non-modulating ones have a different set of rules. We're going to look at the heat exchanger. I mentioned those little turbulators on there. This is just kind of showing you that. So there's stainless steel tubes on the secondary heat exchanger with aluminum fins, and then those individual turbulators in each one of those guys to kind of help get us a little more heat transfer through there. The modulating gas valve itself is nothing overly sexy or exciting. It does have an on-off switch, like most gas valves do. So sometimes you might get an error on your Infinity stat saying, "Hey, make sure the gas valve is switched on," and you'll go look at the the red handcock on the outside, and it's to the full flow position, and you think it's on, but there's actually a switch on the inside on the gas valve as well. There is an adjustment screw that you can utilize to set up the gas valve. On these guys, we do not have the technician fire it in 61 stages and test each one. That would obviously not be very realistic. You can fire it in a test mode. You can fire it in low, medium, and high, whereas low is about 40% fire, medium is like 65 to 70% fire, and high is 100% fire. For gas valve setup, most guys are just doing it in low and high, and if you can get the correct gas flow rate at those 2 points, you're in pretty good shape. Some of our competitors' gas valves, going back to the earlier conversation or question, only have the ability to kind of tune things in at one point. We can tune in a low and a high scenario on this gas valve. It is a diaphragm style gas valve. There's not too much that you need to do in regards to servicing it other than setting it up. As with all furnaces and boilers, we do recommend that you are using a combustion analyzer along with your manometer to set up the gas valve. at a bare minimum, the manometer, please, at least. But the combustion analyzer would help you get this thing tuned in a little bit better. I know some folks like to say, oh, well, isn't the factory the one setting up the gas valve? And they do, but they set it up, at their factory, which in this case is Indianapolis, which has a different gas supplier than you have, and the gas has a different caloric value than we have here, so it's not exactly matching what we have. So you do want to use your combustion analyzer to set up any furnaces or boilers or any other gas appliances that you are using in this area. This is a little picture of the blower assembly I was talking about. Like I said, you can take out the screws on this guy and slide this whole blower assembly out. You can actually slide it all the way out of the furnace, and they do give you enough wiring whip down here to actually take this guy out and set him on the ground and then service the variable speed Ecm motor from there. Obviously, you should do that with the power disconnected. But you can pull them all the way out and not have to disconnect any of the wiring in order to get to that motor bell. All right, so let's look at some different things here for the Chicago area. Some of you guys may have seen this chart before, maybe in some of our heat pump classes or in other furnace classes. For right now, we're going to look at the Chicago base scenario. And there are, I'm not sure how many people realize it, but how many hours we have in the year is 8,760 hours in the year total. All right, of those number of hours, if you look at it, this is the number of hours we spend in the heating mode, 6,000. So on days when it's below 65 degrees outside in the Chicago area on an annual basis, 6,000 of the 8,700 hours we are in a heating mode as being defined by less than 65 degrees outside, which is kind of depressing in and of itself. We spend that much time heating in Chicago where we live. If we look at hours above 30, so between 30 and 65, it's 4,500. It's more than half of the hours of the year are between 30 and 65, half the hours of the year. Or if you want to think of it this way, 76% of our heating time, it's between 30 and 65 degrees outside. If you look at 20 degrees, between 20 and 65, it's 90% of our hours. So 90% of our wintertime heating hours are between 20 degrees outside and 65. Well, unfortunately, we can't size your furnace for 20 degrees outside. Because at 20 degrees outside, I'm never going to heat you on the coldest day of the year. If you look at, the ASHRAE handbook, you're probably, depending on which city you're in, you're probably going to see -3, -4, -5 degrees as our design temp. So that's what we need to be designing for. I know some of you old school guys are still using -10. That is not correct, nor is it generally permitted by the new energy code. You need to use the current city data for the 99% value. But let's just say, for sake of argument, -4 degrees outside, but only 20 degrees, and above is most of my hours. So if I give you a regular furnace for, let's say, 80,000 BTUs, like our previous example, designed for a -4 degree day outside, it's great. On the -4 degree day, he's rocking and rolling. He's got all stages fired. He's happy and running. But anytime it's warmer than -4 degrees, he doesn't need all of the stages capacity. And if you only got a one-stage unit or maybe a two-stage unit, it's a little bit harder to keep up with that. If I got a fully modulating unit, I can pretty much give you the amount of BTUs you need at any given time throughout the day. And just for point of reference, all these red hours here, those are heating in Chicago area. So below 65 degrees heating, all these hours added together, this little bit of blue is cooling. A lot of us have gotten really good about talking about SEER and air conditioning efficiency, but it's kind of irrelevant when you think about heating efficiency. Heating gas is cheap, but nonetheless, it still does cost money, and it costs way more than cooling buildings does. Some of you may have seen this chart before. I actually took it out of an old Carrier marketing piece of literature from the 80s, just to kind of illustrate an example, and then I relabeled the labels to make it a little bit different here. But forever, on two-stage furnaces, we used to always sell the big furnace, little furnace concept, right? So I can give you the furnace that heats your house on the -4 degree day or 0 degree day or whatever you're designing for, but all the rest of the time of the year it's too big. Wouldn't it be great, Mr. Homeowner, if I could give you two furnaces, one size, for the mild days of the year, one size for the really cold days of the year. So instead of having my full flame on for a short amount of time, I could have my little furnace running for most of the year, 90% in this case, and then every once in a while when it's, -4, 10 degrees outside, something like that, I got to bring the big furnace on. The modulating furnace does the exact same thing, except it's like having 60 little mini furnaces, each one size for different day of the year, plus the big furnace designed for the -4 degree day outside. So this is kind of what we're trying to do with that gas valve, and this is just a hypothetical example. This is not anyone's specific house. But on this chart down here, we got from -10 to 80 degrees. This is outdoor air temperature. And then up the left-hand side here, we have BTUs per hour requirement, BTUH. So if I picked a -4 degree day, right over here, boom, this house needs 65,000 BTUs. Great. I get them a 65,000 BTU furnace. I should say -4, not -9. 65,000 BTU furnace, everybody's happy. Then what this furnace is going to do is the more mild it is outside, the more it's going to modulate its burner capacity downward. Right? If I only need 40,000 BTUs on a given day because it's 20 degrees outside, fine. I'm only going to run it at 40,000 BTUs. Right? Now this furnace is not actually tracking the outdoor air temperature because that wouldn't make any sense for the furnace to do that because everybody's house has different insulation values. So different outdoor air temperatures will require different BTUs for different houses. So what do you think we track instead of outside air to modulate this? We actually track space temperature, and more specifically, we track space temperature deviation from set point. So what does that mean? That means if your set point is set for 72 degrees on your thermostat or on your Evolution Infinity controller, we look to see are we above or below that with the actual temperature. So if that's our set point and our actual temperature is, let's say, 70.5, great. I'm 1.5 degrees off. I need a lot of capacity. I'm going to be ramping up here on the high end of my burner capacity. But then as I get closer to 72, I get to 71, I modulate back a little bit. I get to 71.5, 71.7, 71.8, 71.9, 72 even. I still got my burner on, whereas a normal thermostat would have shut him off. My burner's still on, but it's at a really small flame, a very low firing rate. And then if I get above 72 degrees, then I'll start backing him off a little bit, right? Back him off, until eventually maybe I will shut him off completely. So I just need to track the difference between indoor temperature and indoor temperature desired, my set point. This is why we need to use the Evolution Connect control or the Infinity Touch control with this furnace, because a regular thermostat doesn't know any of this stuff. He may know the set point, he may know the current temperature, and he may know the deviation, but he can't tell our furnace that. All he can tell our furnace is, I closed the W1 relay for first stage heat. I closed the W2 relay for second stage heat. That's all the regular thermostat can do. He can't tell us how much heat he wants. He can just say, I want a little or I want a lot, but he can't tell us exactly how much. That thermostat can do that. Joel asks, how well integrated are the new Infinity units with modulating gas valves with carrier comfort zone systems? You would not be using this furnace with a carrier comfort zone system because a comfort zone system is doing what I was just describing here with the 1-stage, 2-stage. Comfort zone is basically just a big thermostat with a zone panel, not much different than a Honeywell zoning system. However, if you use an Infinity zoning system, which has been around since maybe 2005-ish or so, that system is extremely well integrated. In fact, it uses the exact same controller as the non-zone system does. And everything I just mentioned where it checks the deviation from set point, it does all of that. So if you have someone who has a comfort zone system, which is an older carrier zoning system like I have in my house, and you want to install this modulating gas furnace, you need to upgrade that system from comfort zone to the Infinity control system. And the way you would do that would be to keep all of your existing dampers, because the dampers are fully backwards compatible, if you will. And you would replace the zoning panel. You would take that off the wall and put the new Infinity zoning panel on, and you would replace the main user interface. And if you had smart sensors, you need to replace them as well. If you had regular remote sensors, thermistors, you could keep those. So the dampers can stay, the actuators can stay, and the thermistor-based remote sensors could stay if you wanted to keep all of those, and just upgrade the zoning panel, the main user interface, and possibly smart sensors if you had that option. But you would not be able to use this system, this furnace, with a carrier comfort zone system, a Bryant Zone Perfect, a Honeywell, a Trollotemp, a California Economizer, or Jackson Systems. None of those systems would be compatible with this furnace. Only a Bryant Evolution zoning system or a Carrier Infinity zoning system are compatible with these modulating gas furnaces, because they need to have that intelligent data sent back from the thermostat to the furnace to say, how far am I from set point? And not only how far am I from set point, how fast am I getting to set point? This uses a PID loop like we've used forever in the commercial building automation world. PID loop, proportional integral derivative. Now, granted, we don't use the derivative term in HVAC very much, so it's really proportional integral. Proportional means how far am I from my set point. Integral means how fast am I getting to there? How close am I getting to the set point? What's my rate of change getting to the set point? And the faster I'm getting there, the sooner I back off. This works exactly the same way cruise control works in your car. You're driving down the highway, you're doing, what do you guys do, 55 miles an hour probably? All right, you're doing 85 miles an hour on the highway with cruise control set. You slam on the brake because some truck cut you off, right? And then you hit the resume button. What does your car do when you hit the resume button? It says you want to go 85, but you're only doing 40. I'm going to gun it. I'm going to go all the way up to the full BTUs, baby. I'm going to ramp it all the way up. But then as I get closer to 85, I get to 78, 79, 80, 81. I start backing off that gas valve. And I want to land exactly on 85. I don't want to stop short of 85. I don't want to overshoot 85. I want to land right on 85 miles an hour. So as I get closer, I back off the gas pedal. This furnace is going to do the exact same thing. As I get closer to the desired temperature set point, I'm going to back off the gas pedal, and I'm going to provide you less and less gas and only give you enough gas to heat your house for your heat loss at that moment. Excuse me. Just like your car is only going to give you enough gas to maintain the 85 mile an hour cruise control set point. No more, no less. Same thing we're doing with this furnace. Exact same thing. And by the way, if you guys that track your mileage on your car, do you get better gas mileage in stop and go type scenarios, or when you got cruise control running at a nice constant speed? I think most of you will say cruise control gives you the better mileage. If you race up to a stoplight and slam on the brakes, and then race to the next one and slam on the brakes and drive it like your 17-year-old son, you're probably not going to get good gas mileage. And that's the same thing that 1- and 2-stage furnaces do. They basically just slam on the gas, slam on the brakes, slam on the gas, slam on the brakes. We don't want to do that. We want to keep everything going consistently. If I have a 2-stage or single-stage furnace and I shut off the gas, my heat exchanger cools down. But when I heat up and cool down metal, what does it do? It expands and it contracts. And when I expand and contract that metal, I'm eventually going to fatigue somewhere. I got 2 different metals connected at some point in that unit, right? 2 different kinds of metal, and they expand and contract at different rates, and eventually they're going to rip apart, and I'm going to get a busted area, and I'm going to get a heat exchanger crack somewhere in that thing. If I keep my gas flowing at a constant rate and I don't turn it on and off, I keep my heat exchanger hot as long as possible, I'm not going to expand and contract as much. And then, at least theoretically in my mind, I should be able to have this thing last longer. So don't think because you're running this thing nonstop that it's going to die sooner. Chances are it's going to last longer than a regular heat exchanger would because I'm not expanding and contracting as much. Similar thing with lights. I'm sure your mom used to yell at you and say, hey, stop flicking the lights on and off. You're wasting electricity. It takes more energy to turn that light on than it does to leave it on continuously, for a certain amount of time anyway. And additionally, it's more likely that the light breaks, the light bulb busts when you're flicking it on and off, on and off. I'm pretty sure that almost everybody's had a light bulb break on them before, and it always breaks when you turn the light on. It doesn't just sit there running fine and then all of a sudden die. It dies when you turn it on, you get that big inrush. So similar kind of thing we got going on here. In terms of the gas consumption, with homeowners, you need to have this conversation with them in advance and explain to them that this furnace is going to be running nonstop a good chunk of the winter. Right? Now, at some point, let me go back here. At some point in time, I'm not going to be able to modulate as low as I want, right? Because 40% is the minimum. Let's just say on this chart right here, this is the 40% minimum line, right? So I'm going to ramp this gas valve up and down, up and down, and up and down. And at some temperature, and in this particular dude's house, let's say it's 48 degrees outside, at some temperature, I'm not going to be able to ramp it down as far as I want, and I'm going to have to go ahead and shut it off. But even then, at least I'm not turning it on between 0 and 100%. I'm just turning it on and off between 0 and 40, 0 and 40, 0 and 40 at these temperatures, right? And then when I get a little bit colder again, 50 degrees or whatever, then I can ramp him up and down again nonstop. The more oversized you make the person's furnace, the more it's going to have to cycle on and off even though it's a modulating gas valve because it only can go down to 40%. So getting the furnace correctly sized is more important than ever with a modulating furnace or even a modulating boiler. Oversizing does not, it's not more forgiving because it's modulating. It's actually worse. So do not oversize the furnaces or boilers. Get them correctly sized for the application, and then let the modulation just help you make things more comfortable. All right, so some of the benefits of the modulation, we get longer heating cycles. Like I said, that's better for the equipment life, and it's significantly better for comfort. Instead of blasting you with 125-degree air and then blasting you with 70-degree air when the furnace turns off, then 120, 70, 120, and 170, just give me 70. We'd rather keep a nice even temperature, 95, 100, 105, 110. Keep it even as long as possible, even but more mild. That'll heat the house more appropriately. You don't get that draft feeling when the burner shuts off. You do get better mixing in the house if you run your variable speed fan continuously, and having the gas flowing at the same time helps along with that discussion. You will stay right on set point. Instead of waiting until you're a degree or two out of set point and then turning the thermostat on and then off and then on and then off, you're going to get very tight control within a couple tenths of a degree. So you'll be right on, nuts on. And it does help out with sound as well. Instead of having to hit high fire and then off, high fire and off, which has a lot of noise associated with it, we're always going to be somewhere in the middle range. We almost never will be at high fire unless it is actually 0 degrees outside. But other than that, we're never going to be at high fire, so it's not going to come up very often. There's only a couple times that this guy's going to run at 100% capacity. One is if it's a design day, right? 0, -4 degrees, -5 degrees, whatever. Okay, fine. Then it runs full capacity. 2, if I come out of setback, right? So say during the day I'm at work and I keep my thermostat set at 60 degrees during the day, and then at 5 o'clock I have it set to go from 60 to 70 degrees. Well, it's going to be 10 degrees off the set point, so it is going to go into high fire for a while to get us up to that set point. So there's a few times that it could go to high fire, but for the most part we're going to be operating at a much lower capacity. We do get a lot of questions about how much it costs to operate these furnaces. There are numerous ways to model this stuff, but one of the easiest ways to do it is with the online op cost calculator. I'm sure most of you have seen this before. If not, if you go to HVAC Partners and log in and go to either Carrier Residential Marketing or go to Carrier Residential Marketing or go to this only shows Carrier, but there could be a Bryant one down here if you're a Bryant dealer. Go to Bryant Residential Marketing, Software Tools, then Online Op Cost Calculator, and you can get to a tool that looks like this. For the interest of time, I already pre-did some examples on here just to kind of show you, and then we'll show you the Bryant one for a while just to get the Bryant guys some airtime over here. So we're showing you here on this tool. It's pretty easy to use. It's a 5-minute tool. You put in your heating load and your cooling load. In this case, I'm just looking at furnaces, so I didn't bother putting cooling in. Where you're at in the world, so we can get some basic weather data on you, how much your fuel costs. And by the way, it's not a buck a therm anymore. It was when I made this chart, but now it's probably more like between 70 and 80 cents a therm when you factor in all fees and costs and everything like that for the Chicago area. If you're on propane, you can switch to that. I'll show you that in a second, where you can put oil in if you're using oil. And then you can put your electric costs in here. And that's between 10 and 12 cents right now for this area, the Chicagoland area. Then you pick your base system, which is usually going to be, well, what do these people own today? Let's say they own an 80% furnace. Great. 80% furnace. For this BTU capacity in that zip code, we're estimating that it's going to cost them $2,800 a year to run. And of that, $2,300 is gas, $500 of it is the actual fan motor. Oops, I did not mean to do that. Sorry. Then you can pick up to 3 more systems here, and I'm going to skip these middle 2 for now because we're not looking at those today. And I'm going to look at the modulating gas furnace 987 MA. It's 97% efficient for the particular size that I had picked. It's going to cost me $2,000 to run it for heating. $82 is for the fan. $1,900 is worth gas. Right, so the variable speed fan, you can see, is doing a pretty good job in itself, taking me from $460 down to $80. And this guy's variable speed fan is even a little bit better than some of these regular ECM motors that are really good compared to the old PSC blower over here, but it's even better with the full variable speed. So all in all, this guy's going to save him like $800. The Carrier example I picked was pretty close to the same example, so it was a pretty similar result for this guy. So I could get someone, a second-tier Infinity system or a first-tier Infinity system, and it's going to be $50 a year difference in operating cost. So, to have modulating gas or not have modulating gas. So really, this system is not going to be sold just on energy efficiency. If you want to sell just energy efficiency and you don't give a crap about comfort, you could sell, the 2-stage Infinity or the 2-stage Evolution. But if they want to have efficiency and comfort, that's when you look at the modulating gas system. Joe asks if the furnace maintains a fairly constant discharge temperature during the entire entire range output, or is it cooler during the ranges of lower fire? The discharge temperature is not always going to be exactly the same, but it's not going to be too cool. We have algorithms in the system that control the blower speed as well as the gas flow. So if we were to keep the blower speed constant and we started lowering the gas flow, obviously our discharge air temperature would drop, and that's fine when I'm going from 120 down to 115, 110, etc. But I don't want it to get too cold, because if it's too cold, people perceive it as being cool. Even though your body is, whatever it is, 98 degrees, on the inside, on the skin surface, it's probably about 92 degrees. So if I blow 80-degree air across your 92-degree skin, yeah, I'm going to heat your house a little bit, but it's not going to feel good on you. So generally, most of our furnaces, we're targeting, I think it's about 104-degree discharge air temperature minimum. It's kind of our goal to keep that discharge air temperature up. So that means we may slow the blower speed down as we slow down the gas flow rate in order to keep the discharge air temperature warmer. And then as the gas flow increases, we can increase the blower speed and so forth. And then we do the same thing with the inducer motor. We have him track the gas valve as well. So yes, it's gonna keep reasonably constant discharge temperature. It's not a fixed number, but we won't let it get below a certain minimum. If you look at propane examples, right? Excuse me, same exact furnaces with a propane example, same story, except because propane costs more, and actually it's probably more than $2 a gallon right now, but because propane costs more, the savings is more. Like we said, this is the most efficient furnace on the market. It's also the quietest furnace on the market. The specific model number here, the 60,000 BTU size, is literally the quietest one you can find, looking at all the sound rating data of every single furnace that's out there. There's also tools to show that to end users because they don't really know what decibels are and things like that. Greg asked if the control monitors discharge air temperature. The furnace control does monitor discharge air temperature in a roundabout way, but it's not going to be displaying that to someone on the thermostat, or it's not something you can change and adjust and things like that. It's just something that's baked into the furnace algorithms to make sure that we don't have cool discharge air on people. So yeah, it kind of monitors discharge air, but it's not something you could see or change or adjust or anything like that. All right, so back onto the sound discussion. If you want to be able to illustrate to a homeowner how quiet the furnace is going to be, other than installing one at your house and taking your customer to your house to listen to it, which sounds probably pretty creepy when you present it to a homeowner, so they probably won't go for that. Or if you got one in your shop in the showroom, you could do that. But there's also a tool you can use, on your iPhone or just on a regular website. There's a Bryant website and there's a Carrier website that have this. We call it the sound comparison tool. So you can go to bryfurnaces.com or cacfurnaces.com, or you can go to H3AC Partners and download the app version for your iPhone or your iPad. Or if you're a Bryant dealer, it's built into the Bryant Pro app as well. So what these guys do basically is they allow you to pick the furnace that you're talking to someone about, say in this case the Bryant 987 MA modulating gas furnace, and you can pick a second furnace, which could be a different Bryant furnace or it could be a competitor's furnace. Now every single competitor's furnace is not in there, but all of the top line ones are. So all the ones that they market as their best, top of the line furnace, those ones are in there. So what the factory did, the Bryant Carrier factory did, is bought all of those furnaces from those manufacturers, brought them into their sound lab, hooked them all up and ran them, and had a microphone sitting there in a certain spot X feet away and recorded the sound of these furnaces, right? And then took that one out, put the next one in, that one out, the next one in, then put the Bryant ones in and the Carrier ones in and recorded all of these ones. So on this sound comparison tool, whether it's the website or the app, you can play what it sounds like in low fire, what it sounds like in high fire, and what it sounds like during startup mode for the Bryant or any of the competitors' furnaces. You can play the Bryant one and then play somebody else's one and then show the customer that way, which one's better. When it comes to these modulating gas furnaces, I think you're going to find the Carrier and Bryant ones are in fact the quietest ones. If you're looking at some of the other Carrier and Bryant furnaces, like a regular, performance 2-stage or whatever, it may not be the quietest one in that app. There may be some ones from Lennox or somebody that are quieter, because remember, in that app, we have all of our furnaces in there, but only the top line competitors. So don't grab a entry-level Carrier one and try to compare it to a high level of someone else, because it's probably not a fair comparison. But if you're looking at these modulating gas fully variable speed ones, it's going to kick everybody else's butt. You can see here on the app, it shows you the decibel ratings if you want that, but more importantly, if you hit low, high, or startup, it'll play you a sound audio clip of what the furnaces sound like when they're running. If you want to download the apps, you can get them from hvacpartners.com. If you don't have a login for that website, you can request one while you're on there. But I don't think you can get these in the App Store. I think you've got to get them from HVAC Partners. All right, I think I've used up my whole entire hour, and I think I answered all the questions I think that came up. If there's more questions that come up after the fact, feel free to send them in. Next week's webinar topic will be on GPS air purification devices. It's at noon next Monday, and actually, is it next Monday? No, wait, next Monday we're off. No webinar next Monday because of the holiday. December 9th is the GPS webinar that Greg Jutras is doing. And then if you're interested, later on today at 4 o'clock, I am broadcasting another webinar for hydronic piping software tools. So if you're interested in that, you do hydronic work and you want some easy ways to learn how to design it and or illustrate it for people, feel free to log in at 4 o'clock for that. You can get there from the Excelsior website, excelsiorhvac.com, or I believe it's also posted on the TEC website, tecmungo.com, and then click on online training, or send me an email and I'll send you a direct link. So hopefully that answers all your questions on furnaces. I don't see any other ones that were added onto the question queue here. If you got other ones, my email is on the screen. Send me an email or call me later, and we'll try to get you any answers to any questions you have. Thank you guys for your time, and we'll talk to you either this afternoon or next week.